Hello everyone. Today I am going to give presentation on the topic home automation. Now we'll discuss about the table of contents. First we'll discuss about the introduction of the project, then the C and C++ topics covered in the internship, then prerequisites of the project and requirements of the project, and we will see the demo of the project. First we'll see the introduction of the project. The purpose of this project is to make home automation using Arduino and Blynk application. This project is stimulated on the Pixim Lab Stimulator and Blynk IoT application. Blynk IoT application is used to control the devices. In this project, we will control the lights, temperature of the home, inflow of water and outflow of the water. Now we will discuss the C and C++ topics that was covered in the internship. At the start of the internship, the basics of C and C++ were taught for us. This topic includes data types, variable, arrays, strings, basic functions, pointers, classes and objects, etc., and like constructors and destructors. Now let's discuss the prerequisites of this project. The first prerequisite is Arduino Uno. It is the mother controller board, that is the main board that we use in this project. Next, Arduino IDE. It is the software that connects the Arduino hardware to upload the programs and communicate with them. Next, Pixim Lab, the stimulator that we use to build the project. Then Blynk application. The software that allows the data exchange between the hardware, Blynk Cloud and app project. Then virtual serial port. It is the software that does not connect to the real serial port but add the functionality to the real serial port. Next, serial remote tank. It simulates the water tank level, that's the inflow and outflow of the water. This is the Blynk app where we control the switches. This is a Pixim lab where we build the project. This is Arduino IDE where we code the project and connect it to the Arduino board. Now let's discuss the requirements of this project. The first requirement is we need to control the garden lights. For this, first we need to read the LDR sensor value. Based on the reading from the LDR, we need to vary the brightness of the LED. It resembles like controlling the garden lights based on the availability of the sunlight. This is the first requirement of our project. Now let's discuss the temperature control system. Now first, when we press the button on the Blynk IoT app, the either heater control or the cooler control, the message will be sent to the Arduino Uno board. From this Arduino Uno board, the message will be sent to the temperature system. Now from the temperature system, we will get the temperature value back to the Arduino board. This Arduino board sends the temperature details and notification to the CLCD and Blynk IoT app. This is the temperature control system. Now let's discuss the second requirement, that is temperature control system. First, first we need to read the temperature from the temperature sensor, that is LM35. Then we need to display the temperature on gauge widget and we need to display the temperature on CLCD. Hereby I have attached the screenshot of this of the temperature control system. Now the third requirement is cooler controller system. First we need to give the button widget, that is cooler button, on the Blynk IoT app as the input. It detects a change in the logic level. If the button widget is high at log if the button widget is logic high, then we need to turn on the cooler. If the button widget is logic low, then we need to turn off the cooler. This is the third requirement of the project. Now the fourth requirement is heater control. Now we need to give the heater button as a button widget on the Blynk IoT app as input. It detects the change in the logic level. If the button widget is at logic high, then we need to turn on the heater. If the button widget is at logic low, then turn off the heater. This is the fourth requirement of our project. Then the fifth requirement is threshold temperature control. Here we need to read and compare the temperature with 35 degrees. If the temperature is more than 35 degrees, then we need to turn off the heater. Then we need to send the notification to Blynk IoT app and display the same on the CLCD. This is the fifth requirement of the project. Now let's discuss the water tank control. Similar to temperature control, from Blynk IoT app, we will just get the details about the inlet valve control or outlet valve control. Whether if we press inlet valve or whether we press outlet valve, we'll send the information to the Arduino Uno board. This Arduino Uno board sends the values to the water tank controller. This water tank sends the value of the value of the volume of the water back to the Arduino Uno. This Arduino Uno sends the volume of the water to and the notification to Blynk IoT app and CLCD. This is the overall view of the water tank control. Now let's see the sixth requirement of our project. We need to display the volume of the water. For this, we need to first read the volume of the water in the tank by sending the commands through serial communication. Then we need to display the volume of the water on gauge widget and on the CLCD. Now the seventh requirement of the project is inlet valve control. Now here we will give the inlet valve button as input on the Blynk IoT app. Similar to heater control, heater button and cooler button, it's also same. It detects a change in the logic level. If the button widget is logic high, then we need to turn on the inlet valve by sending commands to the serial communication. If it is logic low, then we need to turn off the inlet valve by sending commands to the serial communication. The eighth requirement of the project is outlet valve control. Here we will give outlet valve button as the input on Blynk IoT app. It also detects the change in the logic level. If the button is at logic high, then we need to turn on the outlet valve. If the button is logic low, then we need to turn off the outlet valve. Now the ninth requirement of the project is we need to control the volume of the water in the tank. That is, first we need to read the volume of the water in the tank by sending the commands to the serial communication. If the volume of the water in the tank is less than 2000 liters, we need to turn on the inlet valve. Then we need to send the notification to Blynk app and display the same on the CLCD. So these are the 9 requirements of our project. Now let's see the demo of our project. Let me restart the Arduino board. it takes some few minutes. Yeah, this is the CLCD board. This is the temperature system, and this is the serial remote tank. Yeah, just a minute. This is the temperature system, and this is the serial remote tank that controls the water tank control, whether water level of the tank. And this is the Blynk app where we give inputs. That is, this is the cooler button, this is heater button, this is inlet button, and this is outlet button. Yeah, now the project got started. First, the water level in the tank is less than 2000, so the inlet button gets on turned on automatically, and we can also stop the inlet button in middle also. Water gets filled automatically, and we can see the value of the water both in CLCD and in Blynk app. We can also stop in middle inlet button, and then we can turn on. Once it reached 3000 liters, the inlet button gets turned off automatically. Now we can turn on the outlet button. The water gets reduced automatically. We can also turn off the inlet button in middle. See, once the value gets once the volume of the water in the tank gets less than 2000, the outlet button got off and inlet button got on automatically. This is the one of the requirements in our project. So, and again the tank got full, and we get the notification in the Blynk application, and here also we get the display in the CLCD. Now let's see the heater part. Now let me turn on the heater. Now you observe that the temperature of the system gets increased. Once it reached 35, here you get message that temperature is above 35 degrees Celsius. Turn offing the heater. Now we can turn on the cooler, and you see here temperature cooler is turned on, and the temperature gets reduced automatically and comes to room temperature. Now we can turn off the cooler. Here also we get the notification that cooler is turned off, inflow is turned off. Okay, now let's see how this home automation works in mobile dashboard. Let me open the mobile dashboard. Yeah, this is the mobile dashboard of the Blynk IoT app. Now let me turn on the outlet button first. Now when I turn on the outlet button, you see the changes that the water level in the tank get reduced, and when it goes below 2000, it got turned on automatically. Inlet valve, let me turn off inlet valve, and it got stopped. This is the water control home automation. And now let's see the temperature control. Now first let me turn on the heater. When I turn on the heater, we observe that the temperature increases, and when it reaches 35 degrees Celsius, the temperature started, the heater got turned off, and now we can turn on the cooler, and the temperature decreases to room temperature. This is the home automation project in mobile dashboard. So this is my overall project, home automation. Thank you, Emertxe team, for giving me this wonderful opportunity. Uh, Through this internship, I learned many lots of things, like more about Arduinos and Blynk app, and more about the sensors and CLCD, etc. I learned a lot, and it helped me to build my career. And thank you, Emertxe, for giving me this wonderful opportunity. Thank you.